Okay, so I'll just go through it. So what is a ratio? We are already aware that a ratio is nothing but a number that has the format of a fraction, and it compares to quantities and also tells us how they're related, right? I think all of you guys remember that I used to say that suppose boy to girl ratio is 8 to 10, which means for every 10 girls there are 8 boys. So this is called part to part, ratio. And there is also part to whole ratio, where you compare a part to a whole thing or a total, like girl is to total students. We are aware about ratios. I'm not going into deep, but it is needed. That is why I'm just recapping. And the way to simplify a ratio is divide both numbers by the greatest common factor, GCF. How is that? Suppose the ratio is 12 over 6. So the greatest common factor here is 6 itself. So we divide both by 6 and we get 2 over 1, right? So and this is what it is saying. Now, I have a question to ask. Can anybody tell me um, what is actually a greatest common factor? Can anybody tell me? And why do we call it the greatest common factor? Why this greatest time is there? And we also know LCM, right? Least common multiple. So uh, why do we add this term greatest to common factors, and what is it? Can anyone tell me? Yeah, Daniel, go ahead.
Greatest common factor, it's like it's a number between two numbers. Okay, so we have two numbers, and
Yeah,
this number, when we divide both numbers, and when we divide both numbers on this number, they will be at least the least number as possible. Like when we have, for example, numerator and denominator, we will find common factor, the greatest common factor between them, so we can simplify.
yeah, that is quite close. Anyone else want to share any other perspective? Yeah, go ahead. I'm not getting the chance to see you. Just share. Unmute yourself and share.
Thank you, sir. So I think the greatest common factor would be a number, the greatest number uh, with which we can divide both the numerator and the denominator.
Right.
Yeah.
So the greatest common number that we
Mm-hmm.
can use to divide both the numerator and the denominator. The greatest we use, the reason is that both of you are quite right, is that no, well, I'm using the prime factor 3, not the Euclidean method, as you can see, to find the GCF. Okay, so here the GCF is going to be 6. How? Because I have common 2 here is common, so I take the 2, and 3 is also common, and then I multiply. So I get 6. The greatest term comes because 2 can be used to divide 12 and 6. Try to get my point. We can divide 12 and 6, both of the numbers, with 2. Okay. uh 12 and 6 both are multiples of 2. We can also divide 12 and 6 by 3, and we can also divide 12 and 6 with 6. Now, which is the greatest number here? 6 is obviously the greatest number here. That is why 2 and 3 both are common factors, even 6. All of these three numbers are common factors, but the greatest common factor is 6. That is why it is called GCF. And when we divide the numerator and denominator by the GCF, we get the simplest form. Because if we were to divide it by its common factor, like suppose with, if I divided it with 2, I'd get 6 on the top and 3 downstairs, and then I'll have to again use 3 and I'll then get this result. So I'm having to do more work. But if you know the GCF, your ratio is simplified easily. That is why we use GCF, and that is why greatest is put in the first, it is the first word, because we are using the biggest number that can be used to divide both of the numerator and denominator. So I guess was made clear. Okay, just a minute. Zahid, do you want to say something?
I think no, sir.
Okay, no, you were on unmute. So, okay, so getting back, this is something we all know. Now, I'm not going to go into details. The example is just talking about simplifying 18 to 24. We are going to try to find the greatest common factor, and we are going to divide both of the terms, and we'll be able to simplify. So I'm not going to get into this. Okay, a math problem, a very simple math problem. What is it saying? It's saying that a juice mix is made with concrete and and water in the ratio 1:4. Okay, so which means that for every 1 cup of concrete I am using, or I need 4 cups of water. Now if I use 3 cups of concrete, how many cups of water do you need? Definitely in this case, because the math is very simple and already it is 1, that is why I just multiply. The scaling factor is 3, I just multiply it and I get the 12 cups of water. But no, the way to do it is concrete by water is 1/4. Okay, and then I have 3, and this is x. And if I have to get x, I'll get 12. I think we are all aware of this, but I'm just saying that this is a very easy mathematical problem of ratios. Now, my question is, the thing that I just did now, C over W, which is concrete over water, then 1/4 is equal to, no, 3 over x. What is this called? Can anyone tell me? You can just unmute and tell me. Can anyone tell me? All of you are aware of it. What do we call this?
Equivalent fraction.
No, the whole thing.
Do we call it like equality or something?
No, it's not equality. It's take another guess.
Okay, let me guess.
Yeah, sure.
Okay, I think that is an equation.
Yeah, that is definitely an equation because I have the equal sign. But what do we call it? Let me make it
Proportional?
easier. Yes,
Do we
the
call it?
equation of proportion equation. When I have two ratios and they are proportionate because of the existence of the equal sign, I call them proportions. No? Equation of proportions. So we use it to figure out the amount of something that we need based on the information given. And the scaling factor, remember what is the scaling factor? Scaling factor is actually a number that we use to multiply both the numerator and denominator to scale up or scale down the ratio. Like 2/3 can be written as 4/6. So both of the terms I multiplied them with 2. So this is the scaling factor. Okay, now moving on, I think you have guessed it. We are going to now talk a little bit about proportions. Proportions are nothing but equation. We have already seen it. That actually says that two ratios are equal. We are already aware of it. And in proportion, to figure out an unknown variable or unknown quantity, we use the cross multiplication, and it also helps us to check if the proportions are okay. If both side, left hand side and right hand side match, they are okay. So there is an example. You have to find out x. So we do cross multiplication and we can easily get x. Now, a mathematical problem. A car uses 8 liters of fuel for 120 kilometers. How many liters for 75 kilometers? Assume same efficiency. You don't need to worry about that. But how do we do it? We first set up a ratio and then the proportion equation. So what we do it, 8 liters of fuel is required for 120 kilometers. So 8 over 120 equals, I need to figure out what amount of fuel or liters of fuel is required for 75 kilometers, and they are proportional. Obviously, in the mathematical problem, it will be written they are proportional. That is why it is saying assume same efficiency. So, use the same amount of fuel to cover distances. So basically, this is the math, and if we solve it, we'll get the value of x as 5. Okay, so yeah, Daniel, you have a question.
Yeah, I have a question actually.
Yeah.
So since we are having this ratio, okay?
Yes. Yeah.
So can we say that always we will get these ratios? It means that we will have a linear graph equation.
So we are getting into graphs. Now, my thinking is for us to plot a graph, what is it required? Daniel, can you tell me for us to plot a graph, what do we need?
Well, we need actually the points, at least 1 or 2 points, and then we need to the slope.
Right. So we will be able to figure out the slope, but first of all, we need two coordinates, right? For the
Yeah.
x-axis and for the y-axis. So, and wait a minute, it's glitching. Right. What is missing here? What do you think? The
Yeah,
equation I wrote.
I think we miss one x coordinate.
We have the x coordinate, suppose. We are missing one more variable, right?
Yeah.
Because it is only giving us the value of x, but we don't know for which value of y. So suppose if I had like this, 8y over 120 is equal to x over 75. That is something I can plot in the graph, and then I can say how the graph will look like. For a simple shortcut, if the independent variable's degree or power, if it is 1, then the graph is going to be linear. Okay, I'm going to talk about it later in the next class.
Yeah.
But know that if this is the independent variable, the independent variable's degree of freedom is 1 or its power is 1, then it is going to be a linear curve. Okay, I don't know if it is it is the right equation. I have to check, but I'm just saying. So to answer your question, we need two variables, one dependent and independent, to plot them on the graph, and then we can actually say that if they are going to be linear or not. But it looks like they are going to be linear because the degree of freedom of x here is 1. So if it was 2, then I think it would have been a polynomial, and maybe it will look like parabola. So I'm going to talk about it in the next class, but I guess Daniel, I was able to answer a bit.
Yeah, thank you so much.
Okay, thank you. Now we are going to go into graphs today, so thank you for getting us started. But before that, let us talk a little bit about rates, unit rates, and distance break time. What is a rate? It is also nothing but a fraction. So a rate will have a numerator and a denominator. Okay, a rate compares two different units. This is its speciality. Two different units mean, so basically, as I know, rate will have the format of a fraction. So definitely numerator will be a digit. Suppose it's 7, just writing. And the denominator is also going to be a digit. But their units are not going to be the same. For suppose for 7, the unit is going to be meter, and for 10 the unit is going to be second. So it means 7 meters, it means 7 meters, and downstairs I have 10 seconds. Now the problem with this is that rates mean par means your par means that for you to get the value for 1 unit. So if I divide 7 over 10, the value I get will be the amount of distance per second, which is meter per second. I confused you a bit, so let me just explain it again. Rates mean we are comparing two different units. In this case, I have in the numerator 7 meters and the denominator is 10 seconds. When I divide the value that I get, okay, the value that I get, which is going to be 0.7, it means that 0.7 meters traveled per second. So a unit rate is a rate written per unit. Unit rates help us to compare choices and solve movement problems quickly. This is something we are going to see in a problem. But let us see another problem to know actually what is a rate. Again, in rate you will have two different units. So in this problem you see that 3 kgs of rice costs $18. Find the unit price. Unit price or rate means that you need to know how much does it cost for you to buy 1 kg of rice. So simply you divide 18 by 3 and you get 6. So this 6 is not just a digit or a number. 6 is not just a digit or a number. It has a significance. It means that per kg of rice costs $6. So this is what unit rates mean. Now I have a mathematical question. Can I call 6 a number or is it a digit? Or can I call it both? Can anyone tell me? Yeah, Daniel, go
Okay, let
ahead.
me.
Yeah,
Okay, I think you can call it a number.
And do you think can I call it a digit? What do you think?
No, I don't think so.
Why can't I call it a digit? Just take a guess. It's okay. We are just having a conversation. Take a guess. It's okay. Daniel, do you want to go for it?
Yeah, I actually I thought like we can call it both of them, digit and number.
Yes. Yeah, because the thing is from 0 to 9, I have 10 digits, right? All of these are single digit numbers. So they are digits and numbers at the same time, but they're single digit numbers. I guess now it answers the question. So 6 is a number, but a single digit number. If I had to call 10, is it a digit? No, it's a number. It is a 2-digit number, but now we cannot call it a digit because in mathematics we have only 10 digits from 0 to 9. Other than that, all of the others are called numbers. Okay, now are you guys aware of the equation? This is the same equation, but I will write it in a different way. Are you aware of the equation S is equal to Vt? This is the equation of velocity, Newton's equation. Are you guys aware of it? Have any of you heard of it? Right? You can write in the chat box, you can tell me. Unmute yourself and you can also tell me. I am seeing a chat.
I think like we can call it as if we change it, we can say V is equal to S over T.
Yeah,
So
V is equal to S over T, right? Yeah.
yeah, the distance over the time.
This time, right. Right. So are you guys familiar with this equation, this equation of a motion? So basically there are a few equations. Yeah, I see many of you are saying that yes. So my question is, what is the special condition for this equation? Does anybody know? Either S is equal to Vt or V is equal to S over T. What is the special condition for this equation? Does anybody know? There is a condition. Well, yeah, Roya, go ahead.
Maybe that the denominator cannot be 0.
That is true. The denominator cannot be 0 because it will be undefined. But there is another condition.
Yeah, thank you, sir. May I go?
Yeah, sure.
Maybe acceleration must be equal to 0 because the distance is equal to V naught t plus half gt squared. So I think the acceleration must be equal to 0 for the equation to remain with that part of the left side.
Yeah, you are you are actually right. Yeah, others. Can you guys tell me what do you think? I'll come back to you. You are actually on the right track. Yeah. I see many hands. Just unmute yourself and tell me. I'm not being able to see anyone. Just unmute yourself and tell me.
Yeah, so I don't know if I'm right, but I think it only applies if the object is in linear motion.
Okay. That is also a good observation.
Okay, I
Yeah.
think from the earlier point that it's a linear motion, I think
Yeah.
also we can say like the velocity is considered to be the slope.
Very good observation, but there is a very easy answer. Thank you so much. These are very good observations, but there is a very simple thing to consider is that the velocity is going to be constant. The velocity, although it is the slope actually is a constant. Although it actually indicates the change of y due to per unit change of x. We are going to get to that, but for this equation to work, Anwar, will you mute yourself? Thank you so much, Anwar. Just mute yourself. Thank you. So for this equation to be true, velocity needs to be constant. It's like, you are covering 1 meter. Sorry, per second you are covering 1 meter. It's kind of like that. Or per second you are covering like 2 meters. So it's like 2 meters per second. When I'm saying velocity is equal to 2 meters per second, it means that a car is covering 2 meters per second. So it's like in the first second you cover 2 meters, in the second you are also covering 2 meters. In totality, you are covering 4 meters, but per second you are covering the same amount of distance. So the velocity remains constant for every meter. Okay, so for this equation to work, the velocity needs to remain constant. So if the velocity is constant, then we will not have any acceleration. So acceleration I forgot the equation, but I think acceleration is also going to be 0, if I'm not mistaken. I'll have to check. I forgot. I studied it like 10 years ago, but I think acceleration is also going to be 0. So, because acceleration is the rate of change of velocity. So if the velocity is not changing, it should remain, yeah, it should be 0. But I'll have to check and get back. However, the reason I was talking about it is because of this mathematical problem. Okay, first let me clear this. Yeah, Daniel, go ahead.
Well, I think like the acceleration here should be 0, because if we're going to consider like the velocity is the rate of change, so it's like the first derivative, and this acceleration will be the second derivative,
Right,
right?
right, yes,
Yeah.
yes. You're talking about this, right?
Yes, exactly like that.
ddt over x. Yeah.
Yeah.
Oh, so this is the velocity. We are now going into calculus differentiation. Let's not go into that. Okay, let us not go into that. But yeah, you're true. You're true. Thank you so much. So yeah, it was a nice discussion. Let me change. Let me change. Okay. So a bus travels 60 kilometers per hour for 2.5 hours. Find the distance. So for you to use this equation s is equal to vt, you have to mention somewhere that considering that velocity remains the same. So if you can consider it, only then you are eligible to use these equations. I use this equation. I have whatever the things I have. I know v because v is 60 kilometers per hour, and I have also t, which is 2.5 hours. So I will be able to figure out the distance, which is going to be 150 kilometers. But my question now is, in this math problem, uh, no, let me change the question. Suppose I give suppose I keep all the parameters same, but I want to make the problem a bit complex. What do I need to do? It means that the v is going to be the same, t is also going to be same, but I still want to make the math problem a bit difficult, and I also say that v is going to be constant, which is 60 kilometers, 60. What do I need to do to make the math problem a bit complex? Can anyone tell me? I'm sure all of you know the answer. I'm 110% sure. Anyone wants to give it a try? Maybe I was not able to make the problem. Yeah, Roya, go ahead.
Maybe we can, where it's written a runner moves 300 meters in 50 seconds, we can change this seconds to be minutes, and then
Yeah,
yeah.
yeah. No, no, no. I'm not talking about this one. I'm talking about this, but you have given the answer. The answer is that
Mhm.
um for this, for us to, use this equation, we have to have the units, the same units. Like if velocity is kilometer per hour, time needs to be in hours. If velocity is meter per second, time needs to be in second. You have to convert. So, in order for me to make this mathematical problem a bit complex, I would just written it as, 2.5 seconds, or something that will, if turned, will turn into 2.5 hours. But I would have changed it, the hours, or I would have changed this, second per hour. So then I would have had to convert it to kilometers and then do the problem. But yeah, unit conversion. This is what we are talking about to make the problem a bit complex. Okay, we know speed is equal to distance over time, because sorry, speed is here velocity. So it is going to be distance over time. Now, what is the difference between speed and velocity? Can anyone tell me?
I
I'm
think I
going
can.
out of I'm going out of boundaries, but let's just talk about it. Yeah, go ahead.
Yeah, I think speed and velocity. The difference is actually that velocity is a vector,
Yeah,
and this means
yes.
like it has both direction and
Unit, value,
quantity. Yes,
value and
exactly.
direction. Right, right. So it's like this, right? Yeah. So
Yeah, exactly. We can put
the sign
arrow
of
to.
yeah, the sign of the sign of vector is this. I'm not going to go into. By the way, just a survey question. Or do you guys know what is vector? I'm not going to explain what is a vector, but have you guys heard of it? Let me see. Just write yes. Have you guys heard of it? I see a few. I Is there anyone who hasn't heard of vectors? Can also write no. Okay, I don't see any no's, so I guess all of you have heard of it. But yeah, so we are talking about speed here because we don't need to talk about directions. Okay, now we are now going to get into graphs. So for that, I'm going to talk about, what is a slope, what does it mean? I'm going to get into details, but um, let us look into this graph and try to figure out what is saying. Okay. Why? Yeah. So on the y-axis, I have distance in kilometers. Okay, which is s for us, and on the x-axis, I have time. I guess it's in hours. Let me zoom out a bit. Right. Now, let's just try to understand what the graph is saying. It's very easy that 1 second traveled, I cover the distance of 60 kilometers. Then I travel another second. I cover the distance of, I guess this is going to be 120 kilometers. Meaning in totality I'm covering 120, but from here to here I'm covering 60 kilometers. And then I go another 1 second, which is 3 seconds in total. I am covering 180 kilometers. So if I want to see what is the speed, what do I need to do? I'll just divide the distance with time. So the last distance is 180 and I covered 180 kilometers in 3 hours, right? So then I get the speed as 60 kilometers per hour. So this is what the graph is showing us. And you see here, it's a very linear graph, right? The line is straight, which means, as I said, for us to use this formula, the velocity needs to remain, or the speed in this case needs to remain constant. You see it's constant because I don't see any changes, any non linear characteristics here. Also from the graph, it is dominant that the speed is the same for every hour spent. The same amount of distance is traveled. Now, what is a slope? I'll do another thing. Suppose in the first hour, I travel 75 kilometers. Okay, so let me plot it here. It's not going to look beautiful, but I just want to talk about what is a slope. I know you guys know, but let me just show it, and then we are going to discuss what the theory says. Okay, so let's say in 1 hour I travel 75 kilometers. So let's consider this as 75. So it will be here. It's not going to be accurate, but here. So as the speed remains the same, in 2 hours, I will cover 75 plus 75, right? It is going to be 150, right? Sorry, 2 hours, 150. It is going to be here. So the graph is going to look like something like this. Okay. Now, what is going to be the slope of this curve, or the velocity? Let us consider it as a slope. Slope is denoted as m. So it is going to be 150, the last distance travel, and time 2. So it is going to be 75. And here, let us consider it as m1 and let us consider it as m2. Here it is 180 over 3, which is 60. Now, what is the pattern that you are seeing that you can use to define a slope? Can anyone tell me? This is 75 for this line. This is 60 for this line. From N1 and M2, what do you observe that will help you to define slope? What does it say? Yeah, go
Can I
ahead.
try?
Yeah, Akol, go ahead.
Okay, so from the slope, what we consider, you take any of the 2 points and you come and use them here. But in physics, we usually compare the M1 and the M2.
No. My question is not there. It's a very simple question. I have drawn 2 lines, right? And one line, for this line, the slope is 60, and for this line, the slope is 75. So from these 2 values of slopes, and also by observing these 2 lines, what can you say about slopes? A slope. What can you say? How can you define a slope? This is what I'm asking, based on this thing you see on the screen.
Can I answer?
Yes, sir. Yeah,
Wait a minute. Let Cole try first, and then we can go to others. Sure. Yeah, Cole, just give it a try.
Okay, according to the 2 slopes, I can see that the slope decreases with increase in distance and time.
Yeah, what can I say? That is true. But what is the easier way to say this? When the slope, the value of slope decreases, what do I see? And when the value of slope increases, what do I see in the graph? Akol. Okay, Roya, sorry. Was it Roya who wanted to speak?
Yeah. Yes, sir.
Yes, Roya, go ahead.
So I think we can find the slope here by dividing change in x with
No.
change in
I know. You are going to divide the change in y by x. I get it. But I'm
change in
just trying
y.
to get the simple answer. Yeah, Daniel, go ahead.
sir, can I
Well,
go?
I think
Sorry. Just a minute. Daniel, let me give Abuang a chance. Angelo Abuang, did you want to speak?
Yeah, I want to speak exactly, Professor.
Yes, please.
Yeah, it is Angelo. It is Angelo.
Angelo. Sorry, Angelo.
Yeah, to define uh, the slope.
Yeah.
From what we can see between the M1 and M2.
Yeah.
We can say or on a straight line. That is what I can say.
I did not get the last part. I lost you for a second. Can you repeat?
Okay. Are you getting me?
Barely. Yes, speak
Hello.
again. Yeah, I can get you now. I can hear you now. Guy, do you want to?
Yeah, I was saying.
Yeah. Go ahead.
Yeah. Okay. Okay. I was saying from what we have observed between M1 and M2, we can say that slope is a rate of change between 2 points on a straight line in the graph.
Yeah, that is the definition. I get it.
You get it?
But I do get it. But what I am saying is that when you see that the value of slope is decreasing and increasing, what is the change that you see in the graph that can help us to define slope? Do you get my question? Your answer is absolutely correct. But based on the graph, what can you say? Okay, Guy, do you want to give it a try?
Yes.
Yes. Go ahead,
I
Guy.
wanted to. Okay, thank you. I wanted to answer a question you asked about this slope.
Yes.
So, in mathematical terms, slope simply shows how steep a line goes on
Right.
either side, whether on the x-axis or y-axis.
Exactly. That is the answer. And I know some of you have already answered, and I think, Daniel, you wanted to say the same thing, but I just wanted to give others a chance because Daniel, you and I have been speaking for a long time. So wanted others to participate. Don't worry, Daniel. I just wanted to hear others, but you are absolutely right, Guy. So, we can define the slope in many ways. First of all, this is the rate of change. It is also, can be defined as velocity depending on the units. But the main thing is that when you look at the value of the slope, because the slope does not have any units, right? So sorry, slope has units. I'm sorry, I'm extremely sorry. But the thing is, when you look at the value of a slope, when you look at the value of a slope, what does it signify? It only tells us how much the line is going to be steeper than the rest of the lines. Like for example, because the slope here is 60, it is quite steep, but when the slope is 75, it is much steeper, right? And steeper means, get this, the rate of change is higher. The rate of change is higher, meaning for this line, sorry, for this line, for one step, for each step, I'm extremely sorry. The problem is that my graphic tab has stopped working. That is why I'm looking at the screen and I don't see my pointer. I'm extremely sorry. Okay, so for this for this line, you say that the slope is 60, means for each step taken for x towards the right, I get a change of 60 for each step, right? Like for 1 second 60, for the second it's 60, third second 60, but in total it's like 180. But for the for this one, for this straight line where the slope is higher, it is much steeper, means that for every step taken towards the right, for towards the x-axis, I am having a bigger change for the y-axis, which is 75. So this is what I wanted to say, and in the chat box I also see the same that you guys are saying, that it tells us how much something goes up and down when we move left to right. It is also same. Christoph is also saying as the line gets steeper, the higher the slope is. True. I also see someone is saying, Michael Shara is saying, if you are walking up a hill, the steepness of the hill is like the slope. Exactly. If you if you want, I can also show you with a small drawing explanation. Thank you so much. Thank you so much. We don't need that for now. But yeah, that's exactly uh, that's what we wanted to say. Just give me a minute. I want to, you know, fix my graphic tab. It's not properly working. Just give me a minute, guys. Thank you. Sorry. Should be working right now. Yeah, it's working. Now, this is nothing new. Evaluating algebraic expressions using substitution just means that you have this equation, although it's not an equation, it's an expression. You have this expression, and you want to evaluate this algebraic expression, and you have the value of x. You just substitute the value of x with 4, and you get the value. So this is what is going on here. We have multi-step equation, we have single-step equation, so we don't need to go into it for now, but let's get to the interesting parts. We are now going to talk about graphs. So, coordinates. I think all of us are quite aware what is this. This is the coordinate plane, this whole thing, and it has two axes because we are now talking about which is 2D, two dimensions. One dimension is towards x. হ্যাঁ আমার জন্য একটু রাখো, আমি একটা টিস্যুতে রাখো না, টিস্যুতে. It's a two-dimension graph because I have two directions. One is towards the x-axis, one is towards the y-axis, right? And in the middle, where both of the axes actually intersect, I called it the point of reference, or 0. And if I go towards the right, the value increases for x. If I go towards the left, it decreases. It does not decrease, actually means it's towards the negative x. And same goes when I go up, positive y, when I go down, negative y. Now, when the values exist in these region, this is called a quadrant. There are, due to these two lines, I have 4 slices or 4 quadrants. These are 4 quadrants. So this is called the first quadrant. In the first quadrant, when you have values here, you see that I'm having to go somewhat towards right, towards the positive x value. Suppose I'm considering this value. Here the value of x and y both are positive. This is the positive quadrant. Now here, suppose this, here the value of x is negative, it is -2, the value of y is positive. So this is our quadrant 2, where we have the value of x as a negative and the value of y as a positive value. Now the quadrant 3, let us consider let me consider this. Now I go 3 steps towards left and 3 steps down, so it's like -3, -3, -3. So this is the third quadrant and this is the fourth quadrant. In the fourth quadrant, I see the value of x is positive but the value of y is negative. You have to remember this, because if you remember this, whenever you look into an equation, suppose you see y is equal to 2x minus 9, instantly you will be able to figure it out, you know, which quadrant this straight line is going to intersect, or which quadrant you will be able to plot this straight line. So that is why it is important for you to familiarize with yourself that there are 4 quadrants, and each quadrant, some quadrants you will have the values of x and y in both positive, in some one negative one positive, and in one you'll have one negative, sorry, both of them negative. Now let us use that. Oh, by the way, another rule is that please keep in mind that when you are plotting graphs, the convention is that you first go towards the x-axis, then you go towards the y-axis. So in this case, when it is written as -4 and 2, the first one before the comma is x, the next one is y. So you have to go -4, means that on the left, towards the left side, you go 4 steps here, and then you have 2, so you go 2 steps, and this is where you see -4 and 2. This is in quadrant 2. So this is the convention. Now we are going to graph linear equations. I have already told you guys that for us to graph linear equations have something in common, where the degree of freedom or the power of x is always going to be 1. Always going to be 1. Here it's 1. Right, so let us plot that. So how do we plot graphs? It is quite easy. First of all, I need an equation to plot, right? And the equation will have 2 variables, one dependent, one independent. So this is the equation. How do I plot it? I start taking some values of x, I put it here. For that I get the value of dependent variable, which is y, and then I start plotting it. So suppose here, let us start with 0. If I plot the value of x as 0, I get -3. Now let me plot the value of x as 1. So I put 1 here. So this is, it is going to be -1. Now let me put the value of x. Now let me put the value of x as 2. 4 minus 3 is going to be 1. Okay, if I plot it here, so to plot, let us plot the values here. So when the value of x is 0, the value of y is -3, it's here. Okay, then when the value of x is 1, I'm not sure, let us consider this as 1. Okay, the value of y is -1, so it's going to be here. And when suppose the value of x is 2, the value of y is 2, it's quite here. So when you have 3 points, you can draw a straight line, a straight line like this, and from this straight line you can actually tell many things. Like graphs are actually used to help us visualize an equation, right? So first of all, this is a straight line. Next is that the slope is positive, right? Because 2 is the slope here. I'm going to talk about it in a few minutes, but this is the slope, this is the positive slope. So positive slope means that from left to right, the values are going to increase. So if you see from left to right, the more I go, the more the value of y increases. Okay, so what I'm trying to say is that when you just look at the graph, it is quite difficult for anyone to imagine all the things that I have just said. But when you have the illustration like this, you can say it like, okay, the slope is positive, definitely. Okay, it also signifies that with the increase of value of x, the value of y also increases, and increases rapidly. It is also a straight line. So this equation is of a straight lines equation. So basically, if we now read to the top, what it is saying is a linear equation graphs a straight line. What is a linear equation? Where the freedom of x, degree of freedom of x is 1, or the power of x is 1. Every point on the line is a solution because it makes the equation true. Definitely, because if you look at this straight line and you take any point, suppose we take this point where the value of x is 0. So if I put the value of x here, I will get the value of y, right? So every point on the equation, on the line, makes the equation true. Means left and right hand side is going to be equal, and for x value I will get a y value. Now, graphing is powerful because it turns equations into pictures. We just saw that. Two reliable methods are table of value, which is this, and other thing is intercepts. Intercepts means that where the line is intercepting the y-axis, where it is intersecting or intercepting. How do you do it? Simple method is that you put the value of x as 0 and you plot the value of y, where you see where actually the line is intersecting the y-axis, not the x-axis, the y-axis. Now, we are going to talk a little bit more about graphs, but let us talk about this. Graph 2x plus y is equal to 6 using intercepts. So for when we are using intercepts, we are going to put the value of x as 0. So if I put the value of x as 0 here, let me first arrange it in such a way that I have y on one side and x and other things on another side. Okay, the dependent variable on one side and the independent variables are and the constants are on other side. So it is going to be y is equal to 6 minus 2x, right? Or minus 2x plus 6. Now, if I put the value of x here as 0, this whole term disappears. I am left with plus 6. It means that in the graph, if this is the graph, suppose this is 1, 2, 3, 4, and this is 1, 2, 3, 4, 5, 6. For x is equal to 0, y is going to be plus 6. 1, 2, 3, 4, 5, 6. Okay, this. Now, The thing I know all of you know, but no, the thing is that you can draw a line like this, you can also draw a line like this. Like, which one do you draw? Can anyone tell me which one do you draw? This is the intercepting point, which is 6 on y-axis. Yeah, Daniel.
Well, here we will look at the slope, and
Yes.
since the x it is negative 2x. This means it's a negative slope, and then
Yeah, the
it's going
slope.
to be downward.
Yeah, the slope is negative 2. It's a negative slope. Negative slope means that from left to right, if you are going, the value is going to decrease. Just look at it. This is a positive slope because from this left side towards right side, when you are going, you see the value of y is increasing. But for this one, from left to right, if you are going, you see that the value of y is decreasing. So for negative slopes, the value of y is going to decrease. So now, as you know, it's a negative slope, so you are just going to draw a line like this, and you will see that after you start plotting the values of x here and you start getting the values of y, you will get all the points on this straight line. Okay, so slopes are very important for us because it helps us to mentally figure out how the line for the equation is going to look like. Okay, now let me zoom out a bit. Sorry. Yeah, you see what is done here is we are trying to figure out. I already drawn the line, but to be absolutely sure, what we do is first we take the value of x as 0 and next we take the value of y as 0. So in the equation, if I take the value of y as 0, what happens is that I get x as 3. So if I put it here, I have two dots, 2 points, two coordinates, and if I draw a straight line that intersects both of the points, the line that I will get, which is this one, will have all the solutions for this equation. All the solutions of the equations are on this straight line. Now I have a question. How many points do you need to draw a line on a curve, on a graph paper? Yes, Daniel.
If it's like
Minimum.
this one, a linear graph, we
Yeah.
need only 2 points. It's
Yes.
enough.
Right. Only 2 points and enough. Then you can ask me a question, sir. Why did you used only, because first time when I did it, I only used x as 0 and I draw the line. It is a faulty method I did it to make you guys understand how the line is going to look like on the graph. But basically what you do is you at least draw two coordinates on the graph. You have 2 points and then you can draw the line. Okay, for straight line, a whole 2 points are enough. Now, slopes. We have been talking about slopes for quite some time now. So let us actually look at the formal definition. But before that, I wanted to talk about something else. Did I not cover that? I wanted to talk about the equation of I wanted to talk about the equation that of a straight line. Did I not cover it anywhere? Okay, let me cover it here. Okay, guys, do you know what is the equation for a straight line? What is the ideal equation for a straight line? Just write it in the chat box. Just write it in the chat box. Very simple. I'm looking at the chat box and waiting. y is equal to x plus b. Okay, it's written y is equal to mx plus c. Okay. Now, my question. If I write Sadaf is equal to slope times Arif plus Sakib, where Sakib is a constant and slope is the slope. This is a dependent variable and this is an independent variable. Am I wrong to write this? Write it in the chat box. Am I wrong to write this when I have defined all the variables? Yes. No, I am not wrong to write it like this, but we do not do it because it is unprofessional and it takes up much space. We use just one character. Now, the equation is, as you have said, y is equal to mx plus c, mx plus bx, whatever you say, all are the same. Y is equal to mx plus c. Now, we are going to look into it. We know y is the dependent variable, x is the independent variable, c is a constant, and m is the slope. Anyone can ask me a question, sir, how do you say this is the equation of a straight line? My answer is that go and plot it on a graph. You will only be able to figure out a straight line for this equation. You cannot get any other kind of lines but a straight line. That is my answer if you are asking how do you know this is the equation of a straight line. Okay, now let us go into a bit deeper. M, this is the slope, and we know that M actually tells us how much steeper the line is going to be. The value of M, when it is decreasing, the line is going to be less steep. So it's like for this the value m is much higher, for this a bit lower, lower than lower. Here the value of m is 0. On the x-axis the value of m is 0, and here the value of m is going to be much higher. Here if it is m1, this is m2, m2 is going to be less than m1. Okay, this is how we know. The slope actually tells us for every step taken towards the right for x, how much change do I see for y? But this c, what does it tell us? This is my question. Yeah, Daniel, go ahead. Do you want to ask a question or like do you want to answer?
No, I'm going to answer.
Yes.
Okay, so this C actually it tells us the it tells us the y-intercept.
Yeah. On the y-axis, where does this straight line intersect? Only one point. On the y-axis, there are thousands of points. This C signifies only one point where the line is going to intersect. Okay, so you guys are aware of this, right? Y is equal to mx. Can you tell me if it is the equation of a straight line, but the C is missing? How is it an equation of a straight line? Write it in the chat box. Just write it in the chat box. How is it an equation of a straight line? Definitely, if I plot on the graph, I'll see that it's a straight line, but the value of C is missing. So how is it a straight line? Yeah, it passes through 0. Anur has also said that the value of C is 0. So C is actually not, it's not like it's not here. C is here, but C is actually here, but the value of it is 0. That is why I did not put it here. So y is equal to mx is actually y is equal to mx plus c, where c is 0. Now, we are all aware of what is a slope. Still, let us read it a bit. Slopes tell you how steep a line is and which direction it goes. Definitely, because if the slope is positive, it's going to be like this. If a slope is negative, it's going to be like this. Okay, and depending on the value of x, sorry, depending on the value of c or b, whichever you say, the constant, if if the slope is negative, it's going to be like either this. You get my point, right? These are the intercepting points, and it will depend on the value of c. But if the slope is negative, it's always going to be like this. From left to right, it is going to be in a decreasing pattern. And if the value of m is positive, from left to right, it is going to show a increasing pattern. So it will look like this. And whichever intercepting point we will have, it will depend on the value of c or b, whichever you say. Okay, so we know that what is the equation of a straight line and how it will look like. So from now on, whenever you look at a equation, you will instantly be able to tell, how that straight line is going to look like on the graph. Okay, now when m is greater than 0, it means rises left to right. I have been explaining this. There is nothing more to explain here. When m is less than 0, which is negative, it falls left to right. So at the left, it is the highest value. When it goes towards the right, the value is falling of y. When m is equal to 0, it's a horizontal line on x-axis. But on vertical line, m is undefined. My question is, why on the vertical line m is undefined? Can anyone tell me? Vertical line means this line, this is the line, y-axis line. Why is m undefined? Okay, Daniel, go ahead.
Well, because like if we take for a specific x value, it will have many y values for that specific x.
What is the value of x here?
The value of x in that one is 0.
Yeah, right. The value of x here is 0, and m means delta y by delta x, right? It
Yeah,
just means
exactly.
the difference, right? So if on a vertical line the value of x is not changing, what is going to be the difference? It is going to be 0, right?
It will be
And
0.
anything in, right, because the value of x is not changing, delta x is going to be 0, right? So if the denominator is 0, our m is going to be undefined. So on a vertical line, the value of x, as it does not change, it actually makes the value of m undefined. Yeah, Mayan, you wanted to say something. Go ahead,
Yes,
Mayan.
actually, I wanted to say that the change in y will be 0, and when you divide 0 by a whole number or an integer, it gives you an infinite value or undefined value.
The value of x if it is 0. Now the question is, suppose
you are talking. Suppose it is x is equal to 3, so the line will be perpendicular to the x-axis, right?
let us do it. Let us put it here. Okay, so we have an equation like that. We are going to go into that. Okay, you just wait a minute. But where I wanted to get is, this is the horizontal line. Here m is equal to 0. How do we have m is equal to 0? Because on this line, whichever the value of x is, you will always get the value of y, the same value, right? So the change is in y is going to be 0. So anything,
Yes.
when you have the numerator as 0, the value is going to be 0 nonetheless. Just the denominator cannot be 0. So that is how on the horizontal line, the value of m or slope is going to be 0. And there is no steepness, right? You have a line like this. Is there any steepness? There's no steepness here. And let us suppose consider it as 3. on the y-axis it is intercepting at the value of 3, and this is 1 2 3 4. So for the value of x as 1, for the value of y I get 3 3 3 3 3. Here you will also see that the slope is 0 because the value of y is not changing. But in this case, where there are many different values of y, but the value of x is continuously the same, the value of x is continuously same, right? Here it's only 3, then the denominator is 0 and you will get an undefined answer. So this is how we see it. And Mayan, I'm going to go into it. What is the equation for x is equal to 0 or x is equal to a constant? What is the equation for y is equal to a constant? We are going to look into this. These are all going to be straight lines, and for both of these equations, one of the variables is going to have a constant value. Okay, so I'm going to go into that, but before that,
Mr.
yes,
Sadaf, so
Daniel.
we cannot, so therefore we cannot call it a function, right?
Because for a function we need a dependent variable and independent variable. This is why you are saying asking the question.
Yeah, when we have the undefined slope, and then we will have like many values, many y values for a specific x, then this one is not a function.
F of x is equal to x plus c. And now ask the question. Daniel, go ahead.
Yeah,
Go ahead.
yeah. I mean, like when we have undefined slope, and this means like for a specific x value, let's say for x equals 2, and then we have a vertical line for x equals 2, y is equal to like unlimited values, right? And that at
Yeah.
that time we will not be able to call it a function.
And your
It's not a
reason
function.
is? Your reason
Yeah,
is?
because my reason is because like for to call it a function, we need to have a specific y value for a one x value.
What you are saying is, for it to be a function, for every value of x you need to get a value of y. This is what you are saying, right?
Yeah, for every value of x, yeah, we should get a value of y, and that's different. Like we cannot take a value of y that has many values of x as a vertical line, for example.
That's a good
Let's
question. I
consider
did
a
not
vertical
think
line.
of it like it. I did not think of
Like
it like it. Yeah, go
I don't
ahead,
know
Daniel.
if I don't know if you get my point. Like we have a vertical line, right?
Yes.
We have, yes. In that case, the vertical line is not considered to be a function.
When you are,
Because at
this
that
is a
time,
vertical lines equation, right? X is equal to
exactly.
c.
Yeah.
And you
So
are
this
saying this is
equation, it's
not
not a function.
this is not a function. This is what you're saying, right?
Yeah.
Yeah, this is a good observation. This is a good
Yeah.
observation. This is a good one. Right, right. Yes. 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 So now moving on. Just a minute. Very interesting thing now we are going to cover. Okay, I need to go for my prayer break. Okay, let's just do this page and then go for prayer break. Okay, now which one should I cover? These are all covered. Okay, right. So two important points for us to consider. We know parallel lines, right? The thing about parallel lines is that they are not never going to cross each other. Like these two are parallel lines. What do you think these two lines have in common for which they are never going to touch each other? That is my question. Write in the chat box. Write in the chat box. What do you think these two lines have in common for them, for which they will never, intercept each other? Yes, the same slope. Both of them. Roy, do you want to say something?
Yeah, I also wanted to say the same slope.
Yeah, when they have the same slope, they are never going to touch each other. And again, if you want to ask me how do you know it, I'll tell you, just plot it and you will have your answer. Just plot it, you'll have your answer. Okay, because sometimes we mistakenly think, like suppose this is 2x plus 9, okay, and y is equal to suppose 2x minus 9. These are two linear equations, right? Their slopes are the same, but they're not the same equation of the same line because the constants are not the same. If you plot them, you will see that because they have the same slope, um, then they will be parallel and never going to be touching each other. But the thing is that when we are considering it, when we are actually trying to imagine it, it's hard to imagine sometimes that two equations having the same slot, how can they not touch? I know it might sound awkward, might not sound feasible to you, but I used to think like that. But when I started plotting it, and then I actually realized that okay, because of them having the same slope, they will never touch each other, because the slope actually tells us for how much per unit of x I go towards the right, the value of y changes. So when the slope is the same, it is actually not letting these two lines get close to each other, because for every value of x they are maintaining the distance because of the slope, because the slope is saying, you know as both of them have the same slopes, the change in y is going to be the same. So that is why they are not letting them come close to each other. Perpendicular line, the slopes are going to be negative reciprocal. So meaning, suppose this is a line, okay, and this is also another line. They are perpendicular to each other because at the point of intersection the angle is 90 degrees, right? Here, suppose the slope for this is m1 and the slope for this line is m2. The For them to be perpendicular, m1 times m2 needs to be -1. Okay, how do we have that? We have to one. How can it be -1? Suppose this is 2 and it is 1/2, it is still 1. Only it is negative when one of the two slopes are negative. Okay, so this is called negative reciprocal, and when you multiply the two slopes, you will get a -1. So when you have a slope and another slope is the negative reciprocal of that slope, you know that the two lines that it will produce are going to be perpendicular to each other. Perpendicular meaning they'll create a 90-degree angle at the intersecting point. Okay, now right, there's nothing to see here. Like this is an interesting example. Find the line perpendicular to, let us do this math problem. This is a very easy problem, but no, if you are asked, no, we will do both of these problems. These are actually important problems. Let's look into the problem 4. So find the line that is perpendicular to y is equal to 2x plus 1. It's a straight line equation, right? So I know that for a line to be perpendicular to this, I have to have the negative reciprocal. So definitely, I'll have to have the m as -1/2, and I have been also given of two values of x and y. Now the equation they are using here, this is called the, if I am not mistaken, this is not the slope equation. This is the, there's a name for, yeah, point slope form. So basically, how this equation comes here. Let me just explain. We know that m is equal to delta y by delta x, which means y2 minus y1 divided by x2 minus x1, and we have m here. So it's like y minus y1 is equal to m times x minus x1. And if you plot the values here of x1 and y1, you will get the equation perpendicular to the equation of this. This is a very important math problem, guys. Do carefully practice it at your home, because in GED mathematical problems many times you are asked that if this is a equation, tell me the perpendicular equation of this or the parallel equation of this. Okay, now guys, I'll need like 10 minutes. I need to finish my prayer. Just take a break of 10 minutes and then we are going to get back to our learning again. Sorry, I guess I took more than 10 minutes, but we don't have that much left. Okay, where were we? Right. So this is just a graphical representation. So this was the equation, y is equal to 2x plus 1, and we were asked in two different math problems to find a parallel equation and a perpendicular equation. In the parallel equation, you will see that the common thing is that both of them will have the same slope, and in the perpendicular equation, you will have the negative reciprocal. Okay, so, and if you plot the graphs, you'll see straight lines and like this, although this line does not look perpendicular to this original line, which is 2x plus 1, but for a line to be perpendicular to another line, it needs to create a 90-degree angle at the intercepting point. So it's a flaw from my end, but they are perpendicular. Okay, simultaneous equations. So basically, simultaneous equations mean is that you will have, let me first do the math problem, right? The inductive process. Let us do the math problem and then it will be very easy for us to explain what it is. So before even jumping into the problem, if you look at it, you see that there are two straight lines. Definitely this line, it will have a positive slope and it will have a negative slope. And we can see that here. This is y is equal to 9 minus x. So minus 1 is the negative slope. So this is the line. And this is y is equal to 2x minus 6. 2 is the positive slope. This is the line. And they will intersect at a point. Okay. So when we have two equations, but there is a single solution that works for both of the equations, we call them simultaneous equations. Okay, and how do we find it? From, let us solve this. First equation, we want to format it in like such a way. I've told you guys that y is on one side and the others are on another side, so this is that way, and we have this. So okay, let me just write it here. Y is equal to 9 minus x, and this is y is equal to, sorry, it will be y is equal to 2x minus 6. Okay, now I am just going to replace the value. So let us consider this. Okay, and I'm going to put the value of, I'm going to put the value of y here. And if we do it and we start simplifying, we will get the value of x, which is 5. We will do the same thing and we are going to get the value of y. We have two equations and we are going to get, so the convention is that if you have two linear equations where there are two variables, you can, you can figure out the values of the two variables. So I have, these are two linear equations because the degree of freedom of x is 1, and then there are two variables. So if I just replace the value of y in this equation or x, I'll get the value of x and y, which is 5 and 4. What does it mean? This coordinate, this point is actually the intersection point. And when I have two equations which will have one solution at the intersection, I will call them simultaneous equations. So let us now look at the explanation. A system of equations is two equations that must both be true at the same time. At the same time meaning, at the intersection point, because this is the same moment in time, the same time. Okay, they have to be true. Each equation is a line. Achha. The solution is the point xy that lies on both lines, so it is where the line intersects. We get it. Now there are three possible outcomes. One solution means that both of the lines will cross only once. There will be one intersection point. No solution means lines are parallel, they'll never meet. Infinite solutions, equations describe the same line. So every point is a solution. Now you might be thinking, sir, how can two different equations can have the same line? Can anyone tell me? A equation, like there is only one straight line, but this straight line can be defined with different equations. Can anyone give me an example of that? I guess not. I know you guys know it. Yeah, Guy Jacques, you can go ahead.
I guess it's a line with infinitely many solutions. Therefore, like maybe it's like a multiple. Like let me say if it is y equals to x plus 6, it's going to be 2y plus 2x plus 12, something like that. It's like
Yeah, you are right. Nothing
infinitely
more than
solution.
that. It's like that. Yes. Yes, it's just scaling up and down. Okay. And we will have many solutions because both of the equations are on the same line. So every point on this line is going to be a solution for both of the equations. Okay. But like when I have these two lines, there are no solutions because they are never meeting, and like for this and this there is only one solution, and these are all simultaneous equations. Okay, now some examples are given. Right, this is, we know these are two parallel lines because the slopes are the same, and this is the one you guys were saying, like x plus y is equal to 3, 2x plus 2y is equal to 6. These are actually on the same line. If you draw it, you'll find the same line because this is just, I'm just scaling, I'm just multiplying by 2, nothing else. So these are the same line but different equations. So your friends, you can ask them this question, like you can quiz them that suppose I have a single line, straight line on a graph. Can you, for that straight line, uh, come up with two different equations. You can ask your friends and see if they know. So this is an equation of that. Now, this is what we wanted to cover, and there is a very simple problem covered here. I don't want to go into it because we are already over time, but you guys can look into it. So that's it for today. We are going to inshallah meet again on the next Friday. So just to give you guys a reminder, let me first stop recording.